Hello, I'm Alexander. Today's build log will be making an Ethereum coin. I thought this would be a fun and cool project to complete with all the hype around different cryptocurrencies this year. Too bad it's not this easy to make 50 cents worth of material and turn into $1,500. As a quick disclaimer, I'm not a financial advisor, nor am I recommending you buy or sell anything. Rather, I'm just a hobbyist who enjoys making stuff. With that out of the way, let's get into the video. As mentioned in the intro, today's video will be on how I machined a physical, real-life Ethereum coin. I chose to mill this on my CNC machine rather than my FDM printer to better create some of the finer details. Aluminum bar stock was selected as the material to be used for this project. Due to some of the modifications I made to my machine, I had to figure out a way to hold my workpiece 1.5 inches off the table. Please comment below if you would be interested in a video where I go over some of the upgrades and modifications I've done on my 3020 CNC. I designed both the work holder and the coin in Fusion 360. The work holder was designed to ensure that when the workpiece was flipped over, the alignment would remain constant. This is important because I machined both sides of the plate and any misalignment between sides would ruin the result. Since I have 10 feet of this 2 by 1/8 inch stock, I had several 1/4 inch holes to clamp down the workpiece from. The .stl files for this jig can be found on my mini factory for free, linked in the description below. Now that the workpiece is ready, I designed the coin itself. I'm still learning the best way to design parts for machining on my CNC, and one of my bad habits is starting off by modeling in the stock and designing around it. For the patterns, I referenced some images I found online and adapted and combined different aspects that I liked. One common theme that I noticed was that most of the existing Ethereum patterns are relatively clean and simple. I also like the idea of a different core material, just like the toonies we have here in Canada. More on this later. Once I was done, I duplicated the file and created a different pattern for the opposite side. At present, I have not uploaded these files as I do not feel like they are super helpful, universal, nor easy to use. On to the most important step, generating the machine code. Previously, I created a custom tool library with crude representations for all my milling bits, which helped to speed up this process. The machining sequence I decided upon was facing the stock to yield a uniform unscratched surface, a 2D adaptive toolpath to carve out the large cavities, followed with engraving or trace operations for the tiny details, and finished with a 2D contour to separate the coin from the workpiece. As a quick note, the footage being shown has been sped up for entertainment purposes. Also, this would not have been possible without my good friend WD-40 providing the much needed lubrication and cooling for the cutter to work while machining. If you plan on machining any metal with one of these hobby CNCs, plan on use some variety of coolant to achieve successful operations. Additionally, I used Mach 3 for controlling the CNC directly from my laptop. For the facing, I began with a 6mm 2-flute nano blue coated carbide end mill for facing with a 0.05mm depth of cut, 15,000 RPM, and 1,000 millimeters per minute feed rate. This yielded a suboptimal result, and backing off did not improve the quality. Later on, I realized that the corner of one of the flutes had chipped off, which was likely the culprit of this visual defect. To correct the facing, I later used a 5mm 4-flute high-speed steel end mill with a 0.02 depth of cut, 15,000 RPM, and 1,500 millimeters per minute feed rate. This resulted in a more desirable surface finish. For the 2D adaptive clearing operations, I used a 0.8mm 2-flute coated carbide end mill. The first pattern I attempted ended up claiming 3 of these fragile bits. On the 4th attempt, I finally found a sweet spot, which enabled me to use the 4th mill for all of the remaining work without failure, at a 0.5mm depth of cut, 16,000 RPM, and 20 millimeters per minute feed rate. The plunge and ramp rates were significantly lower at 8 millimeters per minute just to be on the safe side. For the tiny details, I used both the engrave and trace operations to generate the toolpaths, as I was having issues with the engrave selecting the sketch geometries. The settings I used was 0.5 mm depth of cut, 10,000 RPM, and 80 mm per minute feed rate, with standard PCB engraving cutters included with the original machine. The last operation, 2D contouring, used a 2 mm 2-flute coated carbide end mill running at 0.4 mm depth of cut, 18,000 RPM, and 300 mm per minute. I added 4 tabs that were 0.5 mm thick to prevent the coin from separating, jamming the machine, and getting damaged in the process. Ironically, this caused me some concerns as I believed that the motors were skipping steps, when in fact the car was just moving up and over the tabs. The best problems are no problems. Sadly, my SD card ran out of space and I lost the final few passes of this cut. The only off-camera work that I completed was twisting the coins off the bar stock and gently sanding down the sides. Here are some pictures of the coin after the machining was completed. Some improvements if I was to do a similar project again would be to reduce the depth of both the larger cavities and the engraved text to be more proportional to a common coin. This would prevent the buildup of junk in the nooks and would also allow for smaller, more detailed patterns to fit in the engraved areas. Additionally, adding a 2D contour would help improve the wall surface finish of the large details, as the 2D adaptive leaves a slightly serrated edge as it constantly re-engages with the stock. Originally, I thought this would be the end of the project, but I got inspired by some of the dual material coins that I saw online. First, I investigated machining and pressing in a brass insert, but then decided that using metallic paints would be a better use of my time. Both paints used were from Vallejo's Game Air line. The gold was 72-755 polished gold, and the black was 72-754 gunmetal. I ended up flooding the cavities and used a toothpick to spread the paint more evenly. Once dry, I cleaned up the top surface with some rubbing alcohol to remove the excess paint. Now the coin is officially complete. My favorite pattern is the simple side, as I prefer it over the wireframe emblem. As fun as this project was to complete, I don't recommend undertaking it unless your intent is to enjoy the process or appreciate the trinket. There are many options to buy a similar trinket coin online with a super cheap price and a cleaner finish. The best takeaway for myself was some of the experience gained in generating several different toolpaths for the same component. Thank you for watching. The next video will be on machining a real-life Bitcoin. See you soon.